Hey everybody, we wrapping up polynomials and heading into our last topic, and we just finished this Desmos activity, and I pulled up a students here that did a great job. Hopefully it's pretty clear by now. If you want a graph to go through -4 right here, you could put x plus 4 in the equation, and if you wanted to go through 2, you could put x minus 2 as a factor of parentheses in your equation, and you want to put x minus 3 to hit through a positive 3. So the challenge was, could you guys match up the polynomial graph and type in an equation there? And you had a choice of which ones you kind of wanted to do there. And the last one was this challenge. And I got to give props. Russell figured this last one out. Russell, not sure how you did it. Maybe you can let me know, but fantastic job. You went through the -3 here. So you put x plus 3. And then you got a little creative because, the first degree was obvious, but as we came down the second degree, as I mentioned in the last video, this is called an imaginary root because it doesn't hit the x-axis. So there's not an x-intercept here. It's an imaginary x or imaginary root. And then the third degree going up also does not hit the x-axis. So that's also an imaginary. So we have one real answer, which is -3. If we would take x plus 3 and set it equal to 0, we would solve that and we would get -3. And then we have two imaginary roots. So first, thanks Russell for that. And then we're gonna head to the whiteboard so I can show you exactly why this part right here that Russell wrote gives us an imaginary root. So here we have the equation that Russell came up with to fit that polynomial. And if we use something from algebra, it's called the zero product property. This is how you find your x-intercepts, how you find your roots. It's what we've been doing all chapter, but it just puts a name to what we've been doing. If you take this x plus 3 and you set it equal to 0, that's called the zero product property. Now you go ahead and solve for your x, and we get x equals -3, which he had on his graph perfectly. Now there's an issue when we go to solve the second one. X squared plus 2 is equal to 0. Okay, fine. We subtract 2, no problem. X squared equals -2. How do we get rid of a squared? Take the square root. So square and square root cancel out. You get x by itself, and then we have the square root of -2, which we probably know right now is no solution. I want to jump back to a long time ago in math. Maybe when math was first invented, right? And we had these problems right here. And someone, maybe who worked on a farm or something had 6 items and said, oh, can you divide those into one pile, into one group? Yep, I got all 6. Can I take 6 things and divide them into 2 groups? Yeah, you need to divide them between 2 people. Maybe you're sharing the farm or the land with somebody. You each get 3 of them, whatever they were, cows or watermelons, right? And then you have 6, and can you divide those 6 cows into 3 families? Sure, that's 2. And then lastly, if you had 6 cows, can you divide them amongst 4 families? And someone might say there's no solution. You can't do that. Mathematicians don't like being told there's no solution, right? We have a lot of grit. We've got to come up with an answer, right? If you do divide 6 divided by 4, or if you turn it into a fraction, like if I had watermelons, can I split up 6 watermelons amongst 4 families? Yeah, that would be 1.5 watermelons. So decimals got invented, or 6 divided by 4 would be 3/2 as a fraction. So those got invented, and it was a new type of number. So while we may have wanted to write no solution for the square root of a negative, mathematicians said, hold on, there is a way to come up with that answer because Russell figured it out in the graph. Like it went up and then it came down and went up. It should be another x, right? There should be a couple more x's to this problem. So they decided to call this number that's the square root of a negative an imaginary number. You might see an I to represent an imaginary number. And really what the imaginary number is it's a square root of any negative number. So I'm going to go ahead and bypass this for a minute. Maybe we'll come back to it. And we're going to talk about the square root of any negative number. Like, let's just go ahead and take the square root of 25. We know what that is. That's 5. What if I had a problem that was the square root of negative 25? Instead of saying no solution, you could say, hey, you know what? Let me break this down real quick. Wouldn't this be the same as the square root of 25 times the square root of negative 1? Right? You multiply 25 times negative 1, you get negative 25. Right? So we know the square root of 25 is 5, and this is that number that is an imaginary. So they call I, imaginary, so they call I the square root of negative 1. So we've just taken out the negative part of this. We've done the math that we know how to do, right? Like back in the day when they were splitting up these 6 cows amongst 4 families, like, oh, we can give 1 to each family, but then there's a couple left, right? 4 families could each get 1, but then there's a couple cows left. What do we do with those, right? So we do the math that we know how to do, which is the square root of a positive number, and then instead of decimals or fractions being invented, this is called an imaginary number. So this is 5i. So if I want to do a problem like the square root of 9, we know that's 3. What's the square root of negative 9? Well, that's the same thing as the square root of 9 times negative 1. You can break that up into square root of 9 and square root of negative 1. We know the square root of 9 is 3. And this part right here is imaginary, and it now gives us 3i. So if we go back to Russell's problem that had x squared plus 2, and we set it equal to 0, and we subtracted 2, and we got x squared is equal to negative 2. Remember, x squared means there's 2 solutions. It's a parabola, could hit 2 x's. When we go to take the square root of both sides, that's fine. Just watch, when these cancel out, you're canceling out the 2 answers. So you would want to put x equals plus or minus to get your 2 answers. And then this right here is the square root of 2. And then, because it's negative, it's an I, I'll take that I outside of the square root. Do we know what the square root of 2 is? I don't know, I gotta check my calculator here real quick. Square root of 2, 1.41 we'll call it. So my 2 answers to this x squared problem would be x equals 1.41i and x equals negative 1.41i. There you go. So hopefully that part made sense. Now we're going to practice solving a few problems that may or may not have imaginary numbers in them. So we got x squared is equal to 16. If you wanted to, you could square root both sides. Square root of 16 is 4, but I want you to think first before we do the problem. X squared, that means 2 x's. Aren't there 2 answers that you could square to get 16? 4 squared gets you 16, but doesn't also negative 4 squared, negative 4 times negative 4 should get you 16. So when you're solving a problem, the moment when you take a square root, that's totally fine. Just be aware that the square root takes out the 2 answers. So you can either write x equals and x equals, or you could write x equals a plus or minus and get your 2 answers that way. Okay? I'll go ahead and set up 2 separate answers, because this is the moment where they broke out the 2 answers. I'm going to go ahead and break it down into 2 x's like this. Alright, one of those is the square root of 16. We know that is 4. The other possibility, when you get rid of the second answer, is make it a negative, and then square root of 16 is 4. So now we have our 2 answers. Cool. Alright, on the next one, we have x squared. We can go ahead and take the square root. Just be aware that when you do that, you are getting rid of that second answer. So we just have x equals, right? Go ahead and write the second one, or you can put a plus or minus as a shortcut. What is the square root of negative 16? Ooh, we just learned. We know how to do square root of 16. That's 4. But this square root of a negative is imaginary, just like when those people tried dividing for the first time. 6 divided by 4 was a decimal or a fraction. Right? When we take the square root of a negative, it's an imaginary. So the square root of 16, we know how to do that, is 4, and the square root of any negative number is imaginary. Right? The other option is square root of a negative we know is imaginary, but it could have been a negative 4 as well. So the way that we just did this one, we had 4 and negative 4. Here we're going to have 4 and negative 4, but we're going to have that imaginary. So 4i or negative 4i. Okay? We head over to our next one, and it's a little bit more of an equation. So we might have like a step to do first, and we subtract 1, and then we get x squared is equal to negative 49, and then we go ahead and square root both sides. That gets rid of the 2 answers. So I'm going to put x equals plus or minus for this one. So notice I've done everything a little bit slightly. Here I broke slightly different. Here I broke the 2 x's down. Here I just wrote x equals x equals. Here I'm going to write x equals plus or minus, and that's going to have my 2 answers. What's the square root of negative 49? That's an imaginary number. Square root of any negative is an imaginary number. What is the square root of 49? That's what we know how to do. That's 7. So we have x equals plus or minus 7i. So if I wanted to write this 2 ways, I could write x equals 7 imaginary and x equals negative 7 imaginary. These two are literally the same as writing that 1 up there. So feel free to write it however you want. If you want to write the 2 answers, or are you cool with writing plus or minus? Then we head to our last one, and I just wanted to show this one as a final example. Just something a little bit different happens, but we do the same step that we did here with the x squared plus 1. We get x squared is equal to a negative 7. We take the square root on both sides. That gets rid of the second answer. It gets x by itself, but remember, there are 2 answers, so you can put plus or minus. The square root of any negative number is imaginary. You can put that. What is the square root of 7? I don't know. I don't know the square root of 7. So I could put square root of 7 right here. Make sure the I is not in there. The I got taken out. The I was the square root of negative 1. Right? So that was like that. The imaginary is outside of it. I don't know what the square root of 7 is, and go, it's not 3.5, it's not 3.5. The square root of 7, hopefully that's in your view there, is 2.64, rounded up to 2.65 I'll do. So the way I can write my answer is plus or minus 2.65, and then the I comes from that being an imaginary number. That's how I write 2 x's from that squared up there as my 2 answers.